Black holes always seem to bring a curse of death. In 1916, Carl Schwarzschild first calculated their existence. Months later, he died in World War I. In 1939, Oppenheimer proved stars collapse into singularities. The same day, World War II began. It felt like a warning. Maybe humans weren't ready for this secret. Two groundbreaking papers were buried by history, not just by war, but by fear within science community itself. This fear erupted in London, 1935. The young Indian prodigy Chandrasekhar confidently walked into the Royal Astronomical Society. He calculated that massive dying stars wouldn't just fade, they would collapse forever, until into an infinitely dense point. But the leading astrophysicist, Arthur Eddington, destroyed this idea. He called it nonsense. Nature would never allow it. Eddington feared what black holes meant, a place where physics breaks down. It was a forbidden zone science couldn't reach. Silence followed for 30 years. Then physicist John Wheeler gave it a name: black hole. The name was catchy. It even sounded strange at first, but it stuck. Wheeler had a famous saying, "Black holes have no hair." It means if you throw anything into a black hole, it only keeps three things: its mass, charge, and spin. All other details are erased. It only goes in and never out, just as a perfect cosmic shredder. But standing beside the shredder was the challenger, Bekenstein, in 1972. He made a bold claim. If you pour hot water into black hole, heat vanishes. That would reduce universe's chaos. So black holes must have entropy. This idea angered Stephen Hawking. He thought it was ridiculous. A black hole that traps light couldn't possibly radiate energy outward. Hawking set out to prove Bekenstein wrong with math. He used quantum field theory for calculations. He worked late into the night. Then, he was shocked by the result. Bekenstein was right. At the edge of a black hole, quantum effects play a trick. A negative energy particle falls in. A positive energy particle escapes. To an outside observer, the black hole seems to emit a particle. It's slowly losing mass and evaporating. That is Hawking radiation. That is to say, black holes were not eternal prisons. As radiation takes away energy, they could bleed and die in final explosion. Hawking's math was clear, but no one had ever seen a black hole. That theory needed proof. The greatest possibility was Cygnus X1. Thus Hawking made a bet with his friend Kip Thorne. Is Cygnus X1 a black hole or not? Hawking bet it was not. The wager? A year's subscription to Penthouse magazine. It was a clever bet. If black holes didn't exist, he'd win magazines. If they did exist, he'd lose the bet but win the truth. We all know the result. Hawking lost. Thorne's wife was annoyed by the magazines, but physics celebrated. Yet it created a bigger problem: the information paradox. If a black hole evaporates, what happens to the information it swallowed? In quantum mechanics, information is sacred. Burn a book, and its information is scrambled in the ash and light. But it's never truly gone. You can still work out the content in the book. But Hawking radiation is random. Hawking thought information was truly destroyed inside a black hole. The universe tore that book apart while also lost the ashes. He said that God not only rolled the dice, but also threw them to places where we couldn't see. If information could vanish into thin air, it would break physics. To defend physics, Leonard Susskind declared debate on Hawking. That black hole debate lasted 30 years, until Susskind found a solution: the holographic principle. Think of a soup can. The soup inside is 3D, but all ingredients are listed on the 2D label. A black hole is like that can. If you fall in, from your view, you cross the edge. But to an outside observer, you never do. Your information gets smeared onto the black hole surface, like a 2D hologram. The 3D world inside is a projection from its 2D surface. When the black hole evaporates, that information on the surface is slowly rewritten back into the universe, scrambled but not lost. In 2004, Hawking admitted he was wrong, but this idea is mind-blowing. If it works for a black hole, what about the entire universe? Mathematically, it's possible. Our vast 3D universe might be a hologram, projected from a 2D surface at the cosmic edge. Our bodies and the stars might just be data, just a flow of zeros and ones. In 2019, we saw our first black hole photo, an orange ring 55 million light years away. Math became an image. A black hole isn't just a destroyer, it's the universe's hard drive. It swallows stars, light, and history, then encrypts them on its surface in a code we can't yet read. In this sense, nothing truly dies. What falls into the abyss doesn't vanish. It becomes part of the universe's memory. As Hawking said, black holes aren't as black as they are painted. If you feel like you're falling into a black hole, don't give up. There is a way out. You might return to the stars.